guys. Today there's not going to be any warm-up because we got quite a bit to get through. I want to make sure that we get through it all. First off, you need this page, which should be given to you this morning. And you will also need your notebook out, okay, to take actual notes. This page right here, I just want with you through all of your project stuff. So I just want it like on your desk every single day, just until you memorize it. Okay, and yes, you will end up having to memorize it for your actual test, which is on November, 20th. Okay, which is quite a ways away, but you're still going to have to actually get to know these and memorize them because you're going to be using them on your projects. Now, I will be allowing you guys to actually use the sheets on your project, so do not lose it, okay? Let's just kind of go over a few of these things and just kind of talk about them. Most of these you should already know, okay? Such as sine x is the same thing as 1 over cosecant x because they are reciprocals, right? All right, and vice versa, cosecant x equals 1 over sine x. These over here in the bottom right corner, okay, right here, they are new. All right, these are called reciprocal identities. Okay? It is what happens when you multiply a sine by a cosecant together. Kind of think about what would happen if you multiply a reciprocal together. Let's say 3 over 4 times 4 over 3. What would that actually equal? 1. Okay, if you thought 1, very good. All right, which is why all of these reciprocals actually equal 1, because you can technically cancel the 3 here, cancel the 4 here, right? And what happens if you cancel everything? That's like saying 1 times 1, which equals 1, right? Okay, same kind of basic idea with these. When you multiply reciprocals together, they equal 1. Okay, at the bottom of this page, we're going to actually add a couple things in, okay? So, this is the only time you're really wanting to write on this worksheet, okay? Because this is going to be like your standard guide for all of these problems. All right, sine squared theta plus cosine squared theta equals 1. This is a Pythagorean identity. This is one of the more famous ones. It's one of the ones that we're going to be using a lot in this class. Okay, so you want to get very familiar with it. Okay, why is it called Pythagorean identity? Okay, this is why. Okay, if I had a unit circle, okay, let's see how bad I can draw a circle here. Yeah, that's pretty bad. Anyways, if we had a unit circle, okay, we're going to pretend like that is perfect. And we just had a point on the circle, let's say right there. That point is going to have an x value and a y value, right? Okay. Well, if I actually drew its radius right there, and then drop down a line, just like that, that actually makes a right triangle, correct? Where the distance from the origin to that line is technically your x value of that point, and the distance straight up is your y value, right? Well, using the Pythagorean theorem, I know that y squared plus x squared equals your hypotenuse squared, correct? And what is the hypotenuse on the unit circle? What is every single one of them on the unit circle? It is a 1. Hence, where this Pythagorean theorem identity came from. This right here, sine squared, is the same thing as saying y squared, right? So that's like y squared plus x squared equals 1. So this is kind of where this whole theory came from, okay? Well, I want you guys to write these down just so you guys understand. This is an equation because of this equal sign, right? Which means I can use algebra to actually mess with this thing a little bit. So in other words, if I come over here and move the cosine to the other side, so that'd be like saying subtracting cosine squared x from each side. Just like that. What would that end up being? Like, how would that end up looking like? That would look like sine squared x equals 1 minus cosine squared x. Like that. Okay. Make sure you write this down because you're going to see it again quite often. Okay. Well, did I have to move cosine? Technically, no. I could have moved sine if I wanted to. I just kind of picked one. What would it look like if I moved sine over to the other side? It would look like this. Cosine squared x equals 1 minus sine squared x. Just like that. Okay? That's another one I want you to kind of write down. Just so you have it, so you can have it visually on your notes, so whenever you see it, you understand what it is. Okay. Next thing. If I can add and subtract things to both sides using algebra, I know it is legal as long as you do one thing to one side of an equation. If you do it to the other side as well, it's perfectly legal as far as algebra is concerned. In other words, if I multiplied one side by something and multiplied the other side by the same something, it would be fine. It would be legal. Well, why am I putting it like this? Because I'm about to do something kind of interesting, kind of weird. All right? What if, now I'm going to erase this, so hopefully you have it written down. If you don't, you can pause this tape and rewind so you can watch it again. So you can have it written down. Okay? What if I took this original statement, sine squared x plus cosine squared x equals 1, and multiplied both sides of the equation, because remember you have to do it to both sides to keep balance, by, let's see, 1 divided by sine squared x. What if I multiplied the whole thing by that? What would that look like? Well, that would look like sine squared x over sine squared x. All I'm doing is distributing, okay? Plus cosine squared x over sine squared x equals 1 over sine squared x. Well, just looking at our identity sheet, okay, just kind of look up. We're going to kind of simplify what these actually mean. Well, what is anything divided by itself? Sine squared x divided by sine squared x. That is same thing as 1. Yeah. So plus, well, looking up, what is cosine squared x divided by sine squared x? Okay, well, I don't see any squares, right? But I do see that cosine x divided by sine x is the same thing as cotangent, right? All I have to do is just bring the square with me because it means the exact same thing. So in other words, it looks like this. Cotangent squared x. Just like that. So what would this actually be if I had a 1 over sine squared x? Okay? That would be cosecant squared x. And if you're completely lost, just make sure that you're looking at the top of this page at the identity sheet that I just gave you, because that's where I'm getting all this stuff. Alright, please make sure that you have this statement written down because this is another Pythagorean identity. There are 3 major ones. This is the second one. Okay? And again, I can move these things around. I can move the 1 to the other side. I can move the cotangent to the other side. I can get really creative and move the cosecant to the left and the cotangent to the right. And, you know, I can just really kind of go crazy with it. Just by using algebra. And you're going to have to be able to recognize and spot these in your work. That's what's hard about this, is that you have to memorize these to be able to spot them. Okay? All right. Well, I didn't have to actually do 1 over sine squared x when I was multiplying, right? I could technically have done 1 over cosine squared x. Okay? And this is how we're going to find our third Pythagorean identity. Okay, so what would that actually look like? Let's see. We're multiplying by 1 over cosine squared x, so that would look like this. Let's see. Sine squared x over cosine squared x, right? Plus cosine squared x over cosine squared x. Okay, equals 1 over cosine squared x, just like that. All right, just like the other one, we kind of want to simplify it into nice, easy terms. So sine over cosine, that's the same thing as tangent. Now, since they're both squared, that means your tangent is also squared. Plus, well, anything divided by itself is just 1. So those two cosines are going to turn into 1. Equals 1 over cosine. So what is that? That is secant. And since cosine is squared, so is the secant. All right. This right here is your third Pythagorean identity that you have to know. Okay? Now, that's all of them, I believe. So let's just kind of go on to this part right here. These are 4 tips that I'm going to give you guys. So we're going to use one of these tips on each one of our problems. Sometimes 2 tips, okay? So just kind of go ahead and write these down. I'm going to give you a few seconds to get that down, and then we're going to talk about them, okay? If you haven't finished yet, just keep copying, and we just can kind of start talking about them a little bit. All right. Number 1, get everything in terms of sine and cosine. What that means, let's say if we had a tangent, we would want to change it to sine divided by cosine. Or if we had a cosecant, we would want to change it to 1 over sine. Okay? That's what that means. Number 2, replace using identity. All right? What that actually means is kind of look back at our sheet real fast. If you go, we'll just go back to this page right here to kind of explain it. What that means is that if you see this statement right here, sine squared x plus cosine squared x, I could technically replace it with a 1 because they are equal to each other. They are the same thing. Okay? Now, I could get really creative and change a 1 to a sine squared x plus cosine squared x if I really wanted to. Okay? But most of the time, I'm not going to have to do that. Most of the time, it's going to be from sine squared x plus cosine squared x to 1, okay? But this is an identity. It's where you have 2 things equal to each other, like that. Number 3. Now this is the kind of stuff that we have been doing. I can add fractions together, okay, or subtract fractions together. Remember, you have to find common denominators to do that. Or, now you're going to see this a little later, I can technically separate one fraction into 2 to see if that helps me. with my goal, and you're going to see the goals in just a minute. And number 4, factor if possible. Remember, our main goal when we factor is to see if something will reduce or not. Okay, just like the last couple days. That's the main thing why we're factoring, to see if something reduces. Alright, what does your problems look like? They look like this. Okay? So go ahead and write these down, and then we're going to play with them and see what we can get. Your directions says simplify. Okay? What that means is that you want to get your statement down to either one number or one trig function, like we'll say the number 5, or just tangent, or something like that. That's your main goal. Okay? So let's see. On number 1, what do we got? We have cosecant x times tangent x. Well, which one of these tips could actually help us? Let's see. Well, let's just try one. Let's try number 1, okay? Get everything into terms of sine and cosine, because sometimes you're just going to have to play with it until you get it. Okay? So if I change this into terms of sine and cosine, what would that look like? Cosecant x is actually 1 divided by sine x, just like that. And since these two things are together, that's the same thing as multiplication. Tangent is sine x over cosine x, just like that. Okay? Well, hopefully you guys can see it. I have one sign on the bottom and one sign on the top, so those are going to cancel. And I'm left with 1 over cosine x. Okay? Well, what is 1 over cosine x? That is secant x. And that happens to be one trig function by itself, just like that. And that's our answer. That's how easy these things are going to be. Okay. Number 2. All right. Let's see, what am I looking at? 1 minus sine squared x over sine x cosine x. Well, first thing I notice is that it's already in sine and cosine terms. Okay? Next thing I notice is that I have a square in my problem. And anytime that I see a square, I'm instantly going to check my Pythagorean identities. Okay, just to make sure what I have is 1 or not. Okay? Hopefully you guys are seeing this one right here that we had written down. Cosine squared x equals 1 minus sine squared x, right? Okay? So what is 1 minus sine squared x equal? What is the same thing as? Cosine squared x. So I can actually exchange or replace that. I think that's tip number 2, right? I can replace using an identity. So that would be cosine squared x over sine x cosine x, just like this. Okay. Well, cosine squared x is the same thing as saying cosine x times cosine x, right? So one of these cosines can cancel because I have one on top and one on bottom. And I'm left with cosine x over sine x. Well, what is cosine x over sine x? Cotangent x. And that's my answer. Okay? Number 3. And we're just going to kind of keep playing with these until you guys kind of pick up on it a little bit better. Okay, number 3. I see a whole bunch of things multiplied together. I kind of want them in the same terminology, so I'm going to do tip number 1 again. You're going to notice that tip number 1 is used a lot. Okay? So I'm going to change everything into sine and cosine. So that's going to be sine x times, well, secant is 1 over cosine x times cosine x over sine x. And since everything's a fraction really, I'm just going to put sine x over 1 just for like a placement thing. It's going to help me visually. Okay? Alright, so what's going to go on here? Well, I have a sine x on top and a sine x on bottom, so that's going to cancel. I have cosine and a cosine. So what am I left with? 1. And there's my answer. Alright, number 4. They gave us an actual degree over there. Well, since they are actually the same degree, 45 and 45, okay, technically I could replace it with an x if I really wanted to because they represent the same thing, okay? Since both of these are actually the same, I can just say, hey, that's the same thing as just x, right? I can substitute it. So what is cosine squared x plus sine squared x? Okay, again, I'm looking at those squares. I'm saying Pythagorean identity, okay? And since it's addition, technically, you know, that's the same thing as saying sine squared x plus cosine squared x, right? So what's your answer? 1. All right, number 5. What we have here is a FOIL problem. All right? So the very first thing that I'm going to do is go ahead and FOIL this thing out. All right, let's see what we get. Cosecant squared x, first term by first term, first term by last term, so that'd be plus cosecant x, right? And then minus cosecant x, and then, what is that, minus 1? Looks like that. I have a positive and a negative version itself, so those are going to cancel, so I'm left with cosecant squared x minus 1. Okay? Well, you remember, looking back at your chart, what we had was an identity that kind of looked like this. Remember, right when I see that squared, I'm going to look at my Pythagorean identities, okay? And this is the one that I'm going to be looking at. Well, what is it if I move the 1 over? So minus 1, minus 1. What does that look like? Cotangent squared x equals cosecant squared x minus 1. So the answer to this, if I replace it, is just cotangent squared x. All right. Number 6. Cotangent divided by cosine. Well, I can't do much with that in its current state, so I'm just going to refer back to my easy tip, the one that I'm always going to try to go for, which is change everything to sine and cosine. So this would be cosine x over sine x divided by cosine x, and technically that cosine is over 1. Anyone kind of think about why I did that? Okay. What do you have to do when you divide fractions? You flip the bottom and you multiply, right? So what does that actually look like? That's going to look like this. Cosine x over sine x times 1 over cosine x, right? If I flip the bottom and multiply, well, hopefully you can see the cosines are going to cancel. You're left with 1 over sine x, which happens to be cosecant x. There's our answer. All right, number 7. Okay, what I see right now is a distributed problem, right? So I'm just going to distribute first. Let's see. If I just say that these are multiplying together, that'd be cosecant x times secant x. Remember, you just write them next to each other, represents multiplication. minus cosecant x cosine x. Okay. First thing I always check for, can I collect like terms? In this case, no, because they're not exactly alike, right? So I have to try something else. Let's go back to Old Faithful, change everything to sine and cosine and see what happens. So this would be 1 over sine x times 1 over cosine x minus 1 over sine x times cosine x over 1, technically. Let's go ahead and do our multiplication real fast. So this will be 1 over sine x cosine x minus, that's just going to be cosine x over sine x. Okay. Now remember your goal. You're wanting to get everything to everything down to one thing, right? So changing cosine x over sine x to cotangent right now would not be beneficial because I still need to put my fractions together. And if it's subtraction, that means I need to find a common denominator, right? Which I'm very, very close to right now. What is the second fraction right here missing that the first fraction has? A cosine. So I need to multiply this one by cosine x, right? Go top and bottom. So my common, that's not y'all's bill. Okay, my common denominator would be sine x cosine x, right? Did not do anything to the first fraction, so it's going to be 1 minus, okay, cosine times cosine would just be a cosine squared x, so it looks like that. Okay. Well, what is 1 minus cosine squared x? That's one of our identities, right? When I see that square, I'm thinking identity, okay? One of those Pythagorean identities. That is sine squared x. Divided by sine x cosine x, just like this. One of my sines will cancel, so I'm left with sine x over cosine x, which happens to be tangent x. It's kind of an ugly T. Anyways. Alright. Did I have another problem up there? I think I did. Yes, I did. Okay, number 8. Okay. Well, I see those squares again. So, instantly kind of thinking, hey, is this one of my identities? Right? I mean, that's what I really want to happen. Is this an identity? So I'm going to look at those Pythagorean identities just to make sure, right? Just kind of want to check it out. Alright. 1 plus cotangent actually equal cosecant squared x, right? And then 1 plus tangent squared x is the same thing as secant squared x. Okay? Make myself a little space. Alright, right whenever I got it in this format, it's going to be much easier to actually simplify. Because all I need to do is go back to Old Faithful and switch everything to sine and cosine. So this would be 1 over sine squared x divided by 1 over cosine squared x, right? Flip your fraction and multiply. That looks like this. 1 over sine squared x times cosine squared x over 1. Okay, which gives you cosine squared x over sine squared x. Okay, cosine over sine is cotangent, and then they're both squared, so it's squared x. And there's our answer. number 9. Now I'm just going to kind of keep going with these. We're probably going to run over until the next day, and that's okay. We'll just pick up where we left off, okay? Let's see. Well, I have subtraction problems, so the first thing I want to do is put them together, because remember I want to actually combine everything and reduce everything down to one thing, okay? So that's what I'm going to be doing eventually. But to be able to do that, we really need everything to be in the same term. So go ahead and change everything to sine and cosine. So this would be cosine x over 1 over sine x minus sine x over 1 over cosine x. Well, I kind of want those fractions to be a little bit nicer, so I'm going to flip and multiply both of them. So that gives me cosine x sine x, right? Minus sine x cosine x. Well, those two are actually the exact same thing, so they're going to cancel. What happens if I subtract things that are the same? What is your answer? 0. And that's one number that's okay to get. Alright, number 10. Well, I have a fraction, and I have two things on top, one thing on the bottom, so I really need to, put everything together. I see one sine, one cosine, and then I just see this misfit, cosecant over there. So I really want to change everything to sine and cosine so everything kind of matches, so I can put stuff together. Alright? So cosecant is technically 1 over sine x minus sine x divided by cosine x, right? Now I'm going to put the 1 underneath sine x, so just so, for a visual effect, right? Hopefully you guys are kind of getting that habit, because it's going to be much easier for you if you start doing that. Okay, first thing I need to do is mess with this numerator. I have two fractions up there, and I need to put them together. So I need to find a common denominator, which happens to be sine x, right? So I need to actually multiply this side by sine x. Didn't do anything to the first one, so it's just going to be 1 minus sine squared x, just like that. And then I still have that cosine x down here, right? Hanging about. Okay, well 1 minus sine squared x is the same thing as cosine squared x divided by cosine x, and technically that's over 1, right? Remember the reason why I did that? So I could see that I need to flip that fraction and multiply. So that's going to give me something that looks like this, cosine squared x over sine x times 1 over cosine x. One of my cosines are going to cancel. Which leaves me with cosine x over sine x, which is cotangent x. Okay? I'm trying to do as many as I can so your notes is full of these things, because you're going to be able to use your notes on your projects. Okay? Some of your problems are going to look very, very similar. Number 11. Go ahead and distribute out your tan. Okay, this is the distribute problem again. Okay? Very, very straightforward. So tan x times cotan x plus tan x times tan x, which would be tan squared x, right? Okay. Let's see. Kind of want to put everything in terms of sine and cosine, so I can put everything together, right? So that would give me sine x over cosine x times cosine x over sine x plus, let's see, well, let's leave this tangent squared x alone just for a minute, and you're going to understand why in just a second. what's going to happen to my sines whenever I multiply? They're going to cancel. What's going to happen to my cosines? They're going to cancel. So what does that end up being? A 1. So 1 plus tan squared x, right? Well, that's an identity. What is it going to end up being? Look at our chart. Secant squared x. Okay, number 12. Let's see. I have two things again, so I kind of want to put them together in some way, right? I have most of the stuff in sine and cosine, so let's just go ahead and fix that. Let's go ahead and put everything in sine and cosine. So this would be cosine x over sine x, right? That's cotangent. Plus sine x over 1 plus cosine x. I have two fractions I'm adding, so I need to find common denominators. Remember, the common denominator is just the two multiplied together. Okay, so that would be just sine x times 1 plus cosine x, just like that. Okay. What was this fraction missing? It was missing the 1 plus cosine x, right? And then the other one was missing the sine x, just like that. Okay. I'm going to have to distribute this cosine to both terms, so it's going to end up being cosine x plus cosine squared x plus, well, the next part is sine squared x, right? Okay, sine times sine. Alright, I see something kind of fun. Let's see. This statement right here, cosine squared x plus sine squared x, well, that's an identity. That's just 1. So that gives me cosine x plus 1 over sine x times 1 plus cosine x. Okay? Well, these two terms are the exact same terms, so they're going to cancel, right? Remember, when everything cancels, it's leaving you with a 1 on top. So that's 1 over sine x, which is the same thing as cosecant x. There you go. Alright, I think we have 4 left, so let's kind of get through them. Again, let's see, number 13. First thing I see, hey, that's an identity, right? What is that? That is sine squared x, okay? And I'm multiplying it by cosecant x. Change everything to sine and cosine. Just like that. One of my sines will cancel, right? Which just leaves me with sine x, and hey, that one was pretty fast and easy. Number 14. Cosine squared x plus cosine squared x times tangent squared x. Alright. Well, let's put everything in sine and cosine and see where that takes us. So cosine squared x plus cosine squared x times sine squared x over cosine squared x, right? Okay, these cosines will cancel because it's multiplication. One's on top, one's on bottom. Correct? Kind of looks like that. So what am I left with? Cosine squared x plus sine squared x, which happens to be an identity, which equals 1. Okay? And we're done with that one. That one's pretty fast. Alright, last two. Get them written down and we'll go through them. Let's see. Cosine x times cotangent x plus sine x. Well, we want everything in the same terms, so let's go ahead and change everything again. So times cosine x over sine x plus sine x. Since I have a fraction, I'm just going to kind of put over 1, just to kind of see what that's going to do for me. Okay, the first one, cosine times cosine, is just cosine squared x over sine x plus sine x over 1. Just kind of bring it down. All right, I have two fractions. Need them in these same common denominators, right? Well, that's just going to be sine x, right? So I need to multiply this by sine x to get there. So that's going to give me cosine squared x plus sine times sine is sine squared x. Well, look at there. There it is again. Okay? What does that equal? 1 over sine x, which ends up being cosecant x. There's my answer. Alright, last one, number 16. That one looks pretty tough. Let's see. I bet it's actually pretty easy. Remember, when you're multiplying fractions, you just multiply top by top, bottom by bottom. So 1 times 1 is 1. I'm just distributing, right? So sine x times cosine x is just sine x cosine x, just like that. Minus, okay, 1 times, remember this cosine is technically over 1, like that. Cosine times 1 is cosine x, divided by sine times 1 is sine x, like that. Okay, common denominators, right? Should be sine x cosine x. This fraction is missing the cosine x, right? So it's going to be 1 minus cosine squared x. Okay, well, there that thing is again, right? That little statement, so that's going to be sine squared x. Those Pythagorean identities are everywhere. Sine x cosine x, just like that. One of my sines are going to cancel. That leaves me with sine x over cosine x, which happens to be tangent x. And we are done for the day. You guys did great. There's not going to be any homework today. We're actually going to be practicing this for the next 2 days. Okay? So you'll get plenty of practice. If you weren't able to follow me too well today, this is one of those lessons that might take a day to really, really sink in. Okay? So I hope to see you guys soon.